Hey guys, so in this video we will be implementing a spam classifier using Python and natural language processing. Along with that, our data will be imbalanced in this case, alright. So we will be seeing 3 to 4 techniques on how to deal with imbalanced textual data set, alright. So without wasting any time, so let's straight dive into the implementation. So here, as you can see, I have already uploaded my dataset onto the Google Colab notebook. And just make sure you have selected the runtime to GPU accelerator and save the instance. All right. So the first step is to include all the necessary libraries that we will be using in this video. So these are a couple of libraries that we will be using. So just press Shift Enter. So as you can see, we are going to use an LTK library, which is a standard for natural language processing, and we are going to use NumPy, Pandas, and sklearn also. All right. So in this video, we are going to use the classical knife-based algorithm, a machine learning model, which is really good for textual data. All right. So the first step is loading our data set. All right. So let's say df is equal to read CSV, and the path will be here. Just copy path here. Okay. And I want to separate it with the help of backslash character. Okay, and I don't want any headers. Yeah, I think it's headers. Okay, never mind. And print df shape and df head. All right. So as you can see, we have approximately 5,500 samples and 2 columns. All right, which corresponds to 0 for label and 1 for textual context. Okay. So the next step is to actually, I will just rename the column names because 0 and 1 doesn't make really sense. Okay. So this piece of code will rename the dataset according to your provided labels. All right. So here my zeroth label will be label and one label will be text. All right. And we are going to do an in place method. All right. So as you can see, we have successfully renamed the labels to our desired values. Okay. So the next step is to actually see the count, right? Whether the dataset is imbalanced or not. So for that, we will count the number of labels we have for ham and for spam. So we have a super easy utility for that inside the pandas data frame. So we will say df of label dot value counts. So here, as you can see, for the class ham, we have approximately 5,000 samples, and for the class spam, we have around 747 samples. Right? So that's a really bad data set, or you can say an imbalanced data set. So before dealing with the imbalanced data set, let's see if we have any null values. That is, if we have any length of zero text. All right, sorry, text with zero length. Right? So let's say df dot is null dot sum. So it counts the number of null values, all right, and provide us the sum. So in our case, we have 0 and 0, all right. So we don't have any null cases. So let's just try to calculate the length of each text, each record of this text column, all right. So for that, I will say df of I'll create a new column, say length is equal to df of text dot apply. It will be a lambda function x return length of x, all right. Df dot head. So this line will basically create a new column inside our pandas data frame length, which will keep length of each record. Right. So you will see for yourself now. So as you can see, the first text is of length 111, second is for 29, and so on. All right. So now in this text, as these are unprocessed texts, all right. So these texts will also contain unnecessary words. Punctuations, stop words, and unnecessary symbols. So uh, we need to remove those in order to proceed further. So for that, I will define a couple of utility functions which will help us to clean our text data, right? So these are some utility functions that I have written. So this basically converts every record to a lowercase. This is pretty simple, and this is used to remove all the numerical values, all the numerical characters, only non-numerical characters. All right, and this is important. All right, it is basically lemmatizing function, which basically reduce the words to its original origin word. All right, it's lemma actually. And remove punctuation is easy. Remove stop words, just words which do not contribute to any meaning in the sentence. Those are called stop words. And extra white spaces. All right. So next step is to apply all these functions to our text column. So this is the same way that I calculated length earlier, like this. And in the same way, we are going to apply all these functions. So now let's calculate length again after all these cleaning function, and let's see if we reduced any length. So I'll say length after cleaning is equal to df of text dot apply the same function lambda x len of x. Okay, let's see the head now. So as you can see, we have actually decreased the length of the text. So those were all unnecessary symbols and characters that we removed using these functions. So the next step is to actually convert these labels to integer values, alright? Because we cannot just feed these labels into our machine learning models and expect it to learn anything, alright? So for that, I will create a label map, which will later apply to the label column, right? So as you can see, I have a label map in which I have assigned ham to 0th class and spam to 1 class. And this is just next step is to just apply this label map onto our label column. So now you can see we have converted the uh, string label into integer label. All right. Cool. So the next step, which is the most important step, is vectorizing. So now we have all the text value and the label values after the cleansing function. Now we need to vectorize it in order to feed it to the neural network, or you can say a machine learning model, because obviously machine learning models works on numbers and not on strings. So we need to vectorize the text values. So for that, I will be using the TF-ID vectorizer. So here I have defined my TF-ID vectorizer with the name TF without balancing, because right now we are dealing with an imbalanced dataset, all right? Later we will change it to TF with balancing, right? So this will actually fit and transform your whole text column and will create a sparse matrix, all right? A sparse matrix is a matrix in which the majority of the elements are zero, all right? If you don't have the knowledge on how TF-ID vectorize, I will provide some resources in the description. So just hit Shift Enter to execute this cell. Okay, so now we can see what it looks like. And this, remember, we need to convert it to an array in order to feed it to the machine learning model, right? So TF-WOB, that means without balancing, dot shape. Let's see the shape. So you can see we had earlier 5,572 rows, and for each row we have 7906 features. All right. So that is our sparse matrix, as you can see here. See, this is our sparse matrix which I was talking about. Next, I will just split the data into train and test. So now we have xtrain, xtest, and ytrain, ytest. All right. So we are ready to feed into a naive-based model. So I'll create the model like nb is equal to Gaussian nb and nb.fit xtrain tf wob and ytrain tfwob. All right. Cool. So we have trained our naive-based model. Now the next step is to predict on the x test values and make some predictions, all right, and then to calculate the accuracy. But we don't actually look at accuracy when we are dealing with imbalanced data set, right? We we rather look on other matrices like precision, recall, F1 score, right? So just keep that in mind. That is really important in the field of data science. Whenever we are dealing with imbalanced data set, we do not look at accuracy. We prefer not to look at accuracy and prefer to look at other metrics like we call precision and F1 score. All right. So let's do some predictions now. Oops, actually, this should be my base NB actually. NB. Let's just calculate the accuracy just for the sake. All right. So as you can see, it is 87.9% accurate, but it is not really 87% accurate, all right? Because this is might be overfitting on a data set, right? Because majority of the class is ham and not spam. So let's look at the classification report that will tell us about the precision and recall and F1 score of the model. So hit shift enter. So here, as you can see, the precision is really bad, right? For the ham class, it is 0.98, and for spam class, it is 0.58. And similarly, F1 score and recall. So to improve this, we need to augment our dataset. That is, we need to artificially generate our dataset somehow. So for that, we will be looking at two approaches. The first one will be a random oversampler, which actually is not recommended for textual dataset because it is just our oversampling technique. Right? And other one is the augmentation technique, in which we are going to convert the words into the respective embeddings based on the BERT uncased model, and using that we will be able to generate new sentences similar to those. So that approach is quite useful and better as compared to oversampling. So let's just look at both of them. So for that we need to install two libraries. The first one is NLP org, and the second one is obviously transformers. So it has installed successfully. So I'll just clear the output. Okay. So next I will import the necessary module from the NLP org library, and let's define our augmenter, which will be using our BERT based uncased word embeddings. All right. So this will actually download the whole BERT based uncased model, which is used to calculate or get the contextual word embeddings of the sentence or word. All right. So let's just test how this augmenter works and what does it produce. All right. So for that, I will be taking a sample text from my dataset. Let's say I have taken the 100 sample. Okay. So it has please don't text anymore. Nothing else say. All right. So now we will use our augmenter to augment this sentence and create another artificial sentence similar to this one. All right. So for that, I will say augmented sample text will be equal to my augmenter.augment method. All right. So press shift enter to execute it. Okay, so let's see what it has generated. So as you can see, it says please don't mean text anymore, nothing else should say. So it is quite similar to the original text. So we can use this to augment our dataset. So now I have created a function which will select only the class label which are minority class samples. Okay, and then it will and I have provided 200 samples for just testing purpose. All right. So this will take around 200 samples from our minority class and augment those and append this into the augment text list. All right. And then using this augmented list, we will append it to the original data frame. All right. So that is the only thing which we are doing right now in this function. So before feeding my original data frame to this function, I will just remove the length and length after cleaning columns because we don't have those columns here. All right. So that will throw error if we include it. So we have new df is equal to this. Right. So now we can just feed this df into this function. which will augment our dataset and append it to our original data frame. So this will just create 2000 samples. I have edited to 2000, but for fast performance or due to time being, I will just reduce it to 1000 samples. Alright, you can experiment it with more or equal number of samples you have in majority class. Okay, just hit Shift Enter to execute this cell. Okay, so actually this will take a lot of time. So let me reduce the samples to 200 only. Alright, I don't know why it is happening because also I've selected the runtime type to GPU also. I don't know. Let's just give 200 and let's just run it now. It should take less time. Oh, it says 12 minutes. As you can see, after 11 minutes, we have successfully augmented our dataset. So now let's see the class balances. Okay, all the label dot value counts. So now you can see for the ham class, we have 48 250 25 labels, 4825, and for spam class we have 947 samples. So earlier I'll show you we had around label dot value counts. So as you can see, we had 747 examples for spam class, and now we have 947 examples for spam class because we kept samples to 200. Okay, so it generated 200 augmented samples for us. All right. So now we have to do all the same procedure in order to test this data set. All right, but we need to remember one thing that we don't have to use the augmented dataset for testing purpose because we uh, we always test the our model on the original dataset and not the augmented dataset. So now what we need to do is that we need to train our naive model on the augmented dataset and test on the original dataset. All right. So that is why I'm doing this kind of thing right now. So now let's again create a TF-IDF vectorizer and convert our text into vectors. So now our TF will be TF with aug. All right. Previously it was without augmentation. Cool. So let's see the shape of our train dataset. So it is also a sparse matrix as we have seen earlier. So let's again create a model and fit on the X train TF and Y train TF. Yeah, Y train TF, Y train. All right. Okay, so we have trained the model. So now let's make some predictions and calculate the accuracies, F1 score, precision, and recall. All right, like we did earlier. And you should see that I'm making the predictions on the X test TF, which is uh, coming from here. Also, I actually forgot to convert the X test to X test TF. All right, so I will just do that. So this is how we'll be transforming our X test into X test sparse matrix. All right. So now we can do the predictions. Yeah, we got the predictions, and now let's just simply calculate the matrix. So here we are calculating the confusion matrix, the accuracy score, and the classification report. Okay. So let's hit Shift Enter. Okay, so as you can see, the accuracy has also increased to 91% accurate, and you can see the confusion matrix here. And now you can see that precision is again not so good because we have only increased it by 200 samples, and you can see the recall has increased. For 0 it is zero point 0.9, and for 1 it is 0.99. And so let's just compare the result. So as you can see, recall was 87 and 86 and 9265. So as you can see, our F1 score and recall has increased tremendously. So it is not so good quite right now, but you can make it better. by increasing the amount of samples to provide here. All right. So it's just up to you how you can and you can experiment with it. All right. So yeah, this was about the NLP aug and transformers augmentation. And for some more next few minutes, I will make a separate video for that because this video is going to be is becoming long. So yeah, that's it for this video, and I hope you enjoyed it.